Okay friends, now we are going to continue our LCM HCF class. Some very basic questions of LCM and HCF. Question number 1. Okay, there are two numbers, 5 square into 3 into 2 to the power 4. I am going to write them there. 5 square into 3 into 2 to the power 4. This is the one number. And the second number is 2 square into 3 square into 7 to the power 1. Now these are two numbers we have to find out the LCM. These are two numbers we have to find out the least common multiple. As already told you, LCM contains all elements of individual elements. If you should have watched my LCM lectures later. I am assuming that. So in this number I am going to identify the unique prime numbers. In this number 5 square into 3 into 2 to the power 4, I am going to identify the unique prime numbers. Unique prime numbers are 5, 3 and 2. Unique prime numbers are 5, 3 and 2. And in this number 2 square into 3 square into 7 to the power 1, the unique prime numbers are 2, 3 and 7. So here 2, 3 and 5, here 2, 3 and 7. 2, 3 are common in both the numbers. 2, 3 are common in both the numbers. What is different? 5 and 7 are different. So obviously in the final number 2 will also be there, 3 will also be there, 5 will also be there and 7 will also be there. 2 will also be there, 3 will also be there, 5 will also be there and 7 will also be there. Obviously LCM means that all individual elements must be there in the final number. This is LCM basically. I have already told you. I am not going to explain LCM here again. As if you want to understand LCM again, then go back to my lectures on LCM. I have already explained them. Now, how many 2 are there in the first number? How many 2 are there in the first number? There are 4 2's in the first number, 4 2's. And how many 2's are there in the second number? 2 2's. So obviously, which one is more? 2 to the power 4 is more. So I am going to consider it here as 2 to the power 4. Because obviously 2 to the power 4, keeping 2 to the power 4 in the final number will ensure that in both the numbers, that is 5 square into 3 into 2 to the power 4. And in the second number, that is 2 square into 3 square into 7 to the power 1. 2, all elements of 2 have been counted. Next we comes to 3. The amount of 3 in the first number is 1. 3 to the power 1 is here. And the amount of 3 in second number is 3 square. So obviously we are going to take the larger power, so 3 square will come here. Then comes 5. 5 is absent in second number. In second number you can also write it as 5 to the power 0. 5 is absent in second number, but 5 is present in first number and it is 5 square. So obviously we are going to take it as 5 square. Now 7. 7 is absent in first number, so we can write it as 7 to the power 0. And 7 is present in the second number, that to power 1. So we will write it 7 to the power 1 and we are going to multiply it. And this is going to be our LCM. This is going to be our LCM. How much this will be there? 2 to the power 4 is 16. 3 square is 9. 5 square is 25. And 7 to the power 1 is 7. 16 into 9 is 144 into 25 into 7. And now we should multiply this. 144 in 7 would be 7 4 the 28, 2, 7 4 the 28, 3 and 7 the 7, 108 into 25. It will be something like this. 1008 into 25. How much it is going to become? It is 25 into 1000, so 25,000 plus of 25 into 8, 200. It becomes 25,200. This will be your answer. Okay. I am sure that you will be able to understand this question. I am moving on to my next solution. Next solution is solution number 2. What is the LCM of 12 square, 12 to the power 4, 12 to the power 10 and 20 to the power 6? Obviously this thing becomes very easy. We have to find out the LCM here, and LCM obviously I have already told you final quantity should have all individual elements. So obviously the biggest element here is 12 to the power 10 and the LCM of this number will be 12 to the power 10, as 12 to the power 10 will contain all the numbers. 12 to the power 10 will also contain 12 to the power 2, 12 to the power 4, 12 to the power 10 and 12 to the power 6. All of these numbers individually are contained in 12 to the power 10. So obviously the LCM is 12 to the power 10 is the answer. Moving on to my third question. Now basically you can see the questions. We have to find out the fractions and the minus powers are given. Minus powers means that the power is really in the fraction terms So obviously here the fraction of HCF will come. So let us write down the number in a modified form. It will be 1 by 6. You can see the original question on my blog page. 6 cube, then 1 upon 6 to the power 10, then 1 upon 6 to the power 12. These are basically the numbers. 1 upon 6 cube it is. I'm sorry, this thing is going out of scene. So obviously here the numerators are 1, 1, 1 and 1 in all the numbers, and the denominators are 6 to the power 1, 6 to the power 3, 6 to the power 10 and 6 to the power 12. Now, as told you earlier, the LCM of fractions is equals to LCM of numerator upon HCF of denominators. Is equals to LCM of numerators upon HCF of denominators. I am really sorry, I think I've said the wrong thing. Maybe no, I told you the formula of LCM. Sorry, HCF of fractions is HCF of numerator upon LCM of denominator. This is what it means. It is HCF of numerators upon and LCM of denominators. So the HCF of these fractions will be HCF of numerators. So obviously numerator are all 1, so HCF will be 1, and LCM of denominators, that is LCM of 6 to the power 1, 6 to the power 3, 6 to the power 10 and 6 to the power 12, and this will come out as 1 upon 6 to the power 12. Your answer will be 1 upon 6 to the power 12. And obviously it's 6 to the power 1 upon 6 to the power 12 is equals to 6 to the power minus 12. So answer is 1 upon 6 to the power 12 or 6 to the power minus 12. I will again repeat one fact. HCF of many fractions is equals to HCF of numerators upon LCM of denominators, and obviously the LCM of fractions will be LCM of numerators upon HCF of denominator. This you need to keep in mind. So this is the solution of question number 3. Moving to my next question, question number 4. So the ratio of two numbers 5 to 6, LCM and HCF. Now, one more thing. In the LCM HCF theory, I already told you, two numbers, suppose there are A1, A and B, A1 and B1. Suppose there are these two numbers, A1 and B1. This is comma. A1 and B1 are two numbers. Now, if we suppose that the LCM of A1 comma B1 is L, and HCF of A1 comma B1 is H. So kindly remember that product of A1 comma B1 will be the product of LCM and HCF. That means A1 into B1 will be equals to LCM into HCF. So this is a very simple thing that you need to remember, that if there are two numbers A1 and B1 and their LCM is L and their HCF is H, then obviously the product of those two numbers, that is A1 into B1, will be the product of LCM and HCF. Now what the question says here? The question says that the ratio of two numbers is 5 is to 6. Coming back to my question. Ratio of two numbers is 5 is to 6. So you can suppose the original number is 5k and 6k. And I'm assuming it 5k 6k because the reason told you in the ratio and proportion lecture. Kindly check the ratio and proportion lecture. So 5 is to 6, 5k is to 6k, HCF is L9 and LCM is 270. HCF is 9, LCM is 270. So obviously the formula becomes 5k into 6k is equals to HCF 9 and LCM 270. Let us solve this thing. It becomes 30k square is equals to 9 into 270. It becomes k square is equals to 9. K is equals to k square equals to 9 square, k is equals to 9. So obviously k becomes 9 and the two numbers are 5k and 6k. So obviously k is 9, so one becomes 45 and another becomes 54. So the answer is 45 and 54. Moving on to my next question. Question number 5. The multiplication of two numbers is 20,000. Their LCM is 800. Find the HCF. Obviously, I have told you the concept backstage. Product of two numbers is 20,000. Obviously, it will be equals to LCM into HCF. The LCM is being given to us. It is 800. We have to find out the HCF. Suppose HCF is H, and here the number is 80,000. So HCF will come out as 20,000 upon 800. We are going to get the answer as 25. 25 is HCF. It is an easy one. Next, question number 6. Okay, least number which when you add by 4, 6, 7, 8, 9, 12 leaves a remainder of 3. In each case, this is LCM model 1. I have already explained you LCM model 1, and according to the LCM model 1, I am writing the answer straight away here. It is LCM of 4, 6, 7, 8, 9, 12 plus of 3. Outside there is a constant k, but here the least is the k, so k will be equals to 1, and so it will come out as simply LCM of 4, 6, 7, 8, 9, 12 plus of 3. If you are not able to understand why I am saying in this way, I will advise you to go back and see my LCM videos. Now we have to calculate the LCM of 4, 6, 7, 8, 9 and 12. 8, 9 and 12. So obviously the LCM of 4 and 6 is 12. LCM of 4 I will calculate in a very different way. Where it is, LCM of 4 and 6 is 12. So this 12 comes out from this, and that this 12 is also completed. And obviously if you are going to consider this 9 in it, then in 112 3 is there. So for completing this 9 is 3 square, so we will multiply 12 by 1 3, so it becomes 36. Then in 36 9 also comes. Then for in order to include in this 36 8, so in 36 4 is already there, and 8 is 4 into 2, so we will multiply this 36 by 2, it becomes 72, and 72 into 7 will becomes 504, and this will be the LCM of this quantity. And in this 504 I am going to add 3. My answer will be 507. I have done nothing. I have calculated the LCM of 4, 6, 7, 8, 9 and 12. How have I done this? First I calculated the LCM of 4 and 6. It is 12. So obviously 4 and 6 is included in 12, and the last quantity 12, that is this quantity, is also included in 12. Now in order to include 9 in the LCM, 9 is 3 square and 12 is 4 into 3. So in 12 there is 1 3, and we have to include one more 3 in order to consider 9. So we will multiply 12 by 3. It becomes 36. Then after that, in this 36 we have to include 8. So in order to include 8, obviously 8 is 4 into 2, and in 36 is 4 into 9. So in 36 1 4 is already there, and we have to include one more 2. So we are going to multiply this 36 by 2, it becomes 72. And in order to, in this 72 there is no 7, and 1 7 is left to be considered, which is this 7, and therefore 72 into 7 will be 504. 504 will be the LCM of 4, 6, 8, 7, 9 and 12, and in this we are going to add 3 to get 507. This is our answer. Next question, question number 7. LCM of the fractions 2 by 3, next is 4 by 9, next is 5 by 6, next is 7 by 12. We have to find out the LCM of these fractions. In order to find out the LCM of these fractions, we are going to find out the LCM of numerators and HCF of denominators. So LCM of numerators, that is the LCM of 2, 4, 5 and 7. So LCM of 2, 4, 5 and 7, how will we are going to calculate 2, 4, 5 and 7. Obviously the LCM of 2 and 4 will be 4. In order to include 5 and 7 in it, we have to multiply 4 into 5 into 7. We are going to get 140. So the LCM will come out as 140 of 2, 4, 5 and 7. And obviously in the base there is 3, 9, 6 and 12. We have to find out the highest common factor. Highest common factor, that is that digit which divides 3, 9, 6 and 12 exactly, and that comes out to be 3. So the answer is 140 by 3. Next question. HCF of fractions 36 by 25, 48 by 25, 72 by 25. We have to find out the HCF of these numbers. I have already told you the formula. HCF of fractions is equals to HCF of numerators upon LCM of denominators. I'm sorry, in this question it is 72 by 75. So obviously here in the denominator we have to write the LCM. The denominator will be simply 75 because 75 consists of this 25 also, this 25 also, and this 75 also. And obviously here we are going to find out the LCM, sorry, HCF, it is numerator, HCF of 36, 48 and 72. So I'm going to write it up, try to write it a bit more clearly. HCF of 36, 48 and 72. LCM I have already getting 72, 75. So now if you are going to find out, first we can write 36 as 4 into 9 and 48 as 6 into 8 and 72 as 8 into 9. But there is no need to do this. Just consider one number 12. 36 is divided by 12. 48 is also divisible by 12. 72 is also divisible by 12. The point here is that I'm not telling you how the HCF of 36, 48 and 72 comes out as 12, because I have already told you in my initial lectures, in my initial videos I have already told you. So I'm directly writing the HCF of 36, 48 and 72 as 12 divided by 75. This is your answer. This is your answer. But you need to consider this fact. You need to consider this fact that if you are going to convert this 12 upon 75 by cutting it by 3, 4 are 12 and 3, and getting it 4 by 25, this 4 by 25 is not your answer. This 4 by 25 is not your answer. Your answer is 12 by 75 only, because when you are going to calculate the HCF or LCM of numerators, then you are not going to rationalize or cut the original terms into the smaller terms. You are not going to do this. If you are going to get the answer as 12 by 75, you are going to consider this only. If you are going to get the answer as 50 upon 30, then you are not going to make it as 5 by 3. It will be 50 upon 30 only. So your original answer is 12 by 75. Keep that in mind. Now coming on to my next question of LCM and HCF. Question number 9. 3 pieces of timber. It is 42 meter, 49 meter and 63 meter long. Now have to be divided to planks of same length. What is the greatest possible length of each plank? Obviously we have to divide them in planks of same length. That is, this has to be divided into planks of same length, this also and this also, and all the planks should be equal to each other. What is the greatest possible length of each plank? The answer is obviously we have to find out the HCF, highest common factor, of 42, 49 and 63. Obviously I'm not explaining you how we are going to find it. It is really easy to find. The answer is 7. I have told you the division method, the multiplication method, everything I have told you about calculating HCF, so I am not telling you this. So we got out 7 as the HCF of 42, 49 and 63. That is, we can say that we can divide all of these pieces of timber into pieces of 7 meter length, into planks of 7 meter length. By dividing them into planks of 7 meter length, we are going to exactly divide all the timber pieces into planks of equal length. Because this 42 is 7 into 6, this 49 is 7 into 7 and this 63 is 7 into 9. So obviously here we are getting 6 planks of equal length, here we are getting 7 planks and here we are getting 9 planks. Total planks came out to be 21, but it is not asked how many planks we have got. It has asked what will be the length of one plank. And the length, this is 7 plus 6, 13, 13 plus 9, 22. The length of one plank will be 7 meters. And this is your answer. Length of a plank will be 7 meters. Obviously, we have to divide it into equal parts, so we have to find out the HCF. That is that element which divides all the elements exactly, and it is the greatest possible such divisor. Next question. Now, 3 different containers contain different quantities of milk and water whose measurements are 403, 434 and 465. The biggest such measure must be therefore to measure all the quantities exactly. Now obviously the 3 quantities that are being given to us are 403, 434 and 465. Basically, we need to find out that this is the exact quantity of milk and water in 3 different containers, and obviously we have to find out the measurement of one container which can measure the sizes of all of these 3 containers in exact quantity. That is, no overflow should be there. So obviously any container who would be measuring all these quantity in exact quantities would have to be a divisor of all of them, and the question is asking what biggest measure must be there to measure all the different quantities exactly. What biggest measure? So obviously it is to divide them exactly, and it should be the biggest measure. So obviously the answer is that we have to find out the HCF. We have to find out their highest common factor, HCF of 403, 434 and 465. Now here I can say that HCF, therefore I am not telling you this, but let me solve this question for you. It will be a sort of revision for you if you are not able to understand me. In the previous question, in the 9th question also, I have not told you the way of finding HCF. In this question, I am once again repeating my way of finding HCF. For 403 and 434, I am going to find my HCF first. I am going to divide 434 by 403. It comes out at 403. Remainder is 31. Then again, I am making this divisor as quotient here, 403. 31 the 31. It comes out as 933. 31 3 the 93. So this 31 was the last divisor in the case of 403 and 434, and so obviously for 403 and 434, 31 is the largest possible divisor. 31 is the largest possible divisor. Now we are going to calculate that is there anything common between 31 and 465. So if we are going to divide this 465 by 31, let us see what happens. It comes out as 5, and by 15 it comes out at 155. So obviously 31 is dividing 465 also. So we can say that 31 is the largest quantity that is dividing all of the 3, that is 403, 434 and 465. So obviously 31 kg will be the measure of that container which is going to measure exactly all the 3 quantities, that is 403, 434 and 465. Now there is one more thing. If you just analyze at this thing, you will see that if in 403 we add 31, we are getting 434, and if in 434 we are adding 31, then we are also getting 465. So obviously they are moving by a difference of 31. So we have to just check whether 403 is divisible by 31, and if 403 comes as divisible by 31, then 434 and 465 will also be divisible by 31, and by this we can also say that the HCF of these 3 quantities is 31. So my answer will be 31, that is 31 kg. Answer is 31 kg. Next question. The least number of square tiles that required to pave the ceiling of a room 15 meter 17 centimeter long and 9 meter 2 centimeter broad. This we have to calculate the least number. So obviously in this 11th one, 15 meter 17 centimeter 9 meter 2 centimeter, it is 1517 centimeter. This is 902 centimeters. We have to calculate what is the HCF, because obviously if there is a room something like this in which this is 1517 and this is 902, and we have to calculate the whole by square tiles like these. So obviously the length of one square tile will be a multiple of this and this both, because one side will be here and one side will be here. So obviously the length of a square tile should be something which is a multiple of 1570 and 902 both. So we have to find out the HCF of 1517 and 902. So using my traditional method, in order to finding out the LCM of 1517 and 902, I am going to divide 1517 by 1902. How this method operates I have already told you. It comes out 5, 6 and 15. Then 902 divided by 615. 615 comes out at 7, 8, 1. 615 divided by 187. It goes around 3 times. 3 times 21. 6. 561 comes out at 4. I think I am making some mistake here. Let me check the mistake. The number is 902 and 1517, 902, 1517, 902, 5, 1, 6, then 902 comes here, 6 and 5, 12, 5, 7, 8. I'm really sorry, this is here where it has gone, my cursor, 287. This is 287. This is 287, and this will not be something like this, will be something like this. Let me clear it a bit. Once you write, it becomes very difficult to clear it. So when we are going to multiply this 287 by 2, we are going to do 2 7s are 14, and this is 2. 2 7s are 14 and 2 8s are 16, so 17, and 2 to the 5 574. So it comes out as 1 and 41. And when we are going to divide this 287 by 41, it is going to divide it exactly 287 0. So obviously 41 is the last divisor, so 41 becomes the HCF of 902 and 1517. So 41 centimeter should be one side. 41 centimeter should be one side of the square tile, one length and breadth of one side of the square tile. So obviously, if there is to be a square tile, this is square tile, it has to be 41 centimeter long and 41 centimeter broad. And what will be its area? Its area will be 41 into 41 centimeter square. Its area will be 41 into 41 centimeter square. Now the question is, least number of square tiles required to pave the ceiling of a room. We came to find out the HCF, that is the largest divisor, which exactly divides 15 meter 17 seconds and 9 meter and 2 seconds. It came out to be 41 centimeters. The area of one square tile came out to be 41 into 41 centimeter square. It came out to be 41 into 41 centimeter square. And obviously, what is the area of the room? Area of the room is 1517 into 902. So this is the area of the room, centimeter square. And what is the area of one tile? 41 or 14 centimeter square. When we are going to divide these two quantities, 1517 into 902 by 41 into 41, we are going to get the number of tiles that are required to cover it, and it will come out as 814. Your answer will be 814. I am not dividing this 1517 into 902 by 41 into 41 because this is a bit cumbersome, and as you can see on this page, there is not enough space to do that. So obviously, I am leaving it here. 1517 into 902 divided by 41 into 41, it comes out as 814. And if you want me to divide it, let us divide it in a new slide. Let us divide it in a new slide. This 1517 902 divided by 41 into 41. Now first of all, in order to divide this 1517 by 41, I should divide it separately. 3 1s are 3, 3 4s are 12, 11 minus 3 8, 4 minus 2 2, 7, 7 1s are 7, 7 4s are 28, 0. So we got as 1517 is equals to come out 37. 1517 divided by 41 came out as 37, and now is remaining for 902 by 41. Let us divide 902 by 41. 82, it remains 8, 82. So what we got at this got us 37 into 22. In order to get what is 37 into 22, first we are going to calculate 37 into 20, it comes out to 740. And in this we are going to add 72 into 2, that is 74. So we are going to get 814. This is the answer. So friends, I am finishing my video here. In the next video I will talk more questions of, I will tell you more questions of HCF and LCM.